So let's explore to some of the use cases that illustrate how the Turing machine is being functioned. So when you can see here, the Turing machine takes the binary input consisting of either 0 or 1, and it negates the value in the adjacent square on the tape. So if you can see this program, the state A handles the transition of the current symbol, and the state B, it determines whether the machine should continue or it has to be halted or comes to the end stage. And the state A, it toggles the value of the current symbol and moves to the right, and the state B ensures that the machine has once the tape is being reached. So you can see the diagram here, the activity diagram, how it's being functioned. So you can see here the another one. Yeah, this is the activity diagram of that. Okay, now my teammate Praveen would continue with the rest of the presentation.
Yeah, let's visualize the Turing machine using unified modifier language. The diagram represents the interaction between the Turing machine and its users. You can see the start state here, and which goes to the state and action, and you can see the symbol where we can see the alphanumeric character and white symbol. So in this we have the left move and right move. So and when we come to the state diagram, Archana, can you go to the state diagram, please?
Oh, sorry.
Yeah, the state diagram depicts the various states of the Turing machine can be how it's transit between the states during operation. You can see the diagram provides a visual representation of Turing machine dynamic behavior, and mainly the implementation details of the Turing machine. Uh, it includes the architecture, input, output of mechanism, and transmission function logic. So the Turing machine architecture is a crucial component to work together to execute computations, mainly tape, read-write head, transition function logic. So when we come to the input-output mechanisms, the Turing machine interacts with the input data through its tape and produce output results through the tape. So the tape is the main function here which takes the input and output. We can see the how the input-output mechanism works in the Turing machine. So initially the input data is loaded onto the tape. So it's read write the loaded data and which gives the output from the tape. So that's the mechanism which works with the tape in the Turing machine. And you can see the transition function logic where we can see the current state, read symbol, write symbol, head movement direction. The movement direction which goes to the left move and right move when it's reading the code, like when the loaded code which goes to the input, and we can see the implementing transition function logic requires careful consideration of task. And yeah, mainly we can see the Turing machine variations. Archana, can you go to the Turing machine variations, please? The 17th slide, yeah. So we can see the Turing machine variations in which the non-deterministic Turing machines and deterministic Turing machines. Mainly the deterministic Turing machines, it determine the Turing machines rules and it's uniquely perform the code. And which comes to the non-deterministic Turing machine, it can be multiple possible transitions. Like when we give the input, the output comes in the multiple ways. So you can see the universal Turing machine, which is the UTM. The universal Turing machine can simulate the behavior of any other Turing machine. It's like function multiple times. So, and mainly I want to talk about the application and significance of the Turing machine. application and significance. Yeah, that one. Yeah, not application and significance of the Turing machine. Yeah, it's a 18 slide. Yeah. Yeah, application and significance of the Turing machine. The Turing machine has far-reaching application and profound significance in the field of computer science. So, in the field of computer science, it's a far-reaching application. So, the theoretical foundation and limitation and compatibility and contributions to computer science. Turing machine impact a major in computer science. It's laid the groundwork for the development of modern computers. So, what we are using the modern computers now, the Turing machine is the main major impact for the programming languages and algorithms which we renovated newly. And compared to the and coming back to the future enhancement by using Turing machines, while the Turing machine is a fundamental concept, there are potential enhancements and extensions due to further enrich the capabilities. So for future enhancement, Turing machine is the main fundamental concept to moderate or to renovate the computers. Multiple tape Turing machines. So the main multiple tape Turing machines, these machines feature multiple tapes and read-write head that can interact with each other. So multiple tape Turing machine is the main part in the Turing machine which can read-write multiple codes. So when we coming to the testing strategy of the Turing machine, the Turing machine implementation is is testing strategy essential. So the performance testing of the Turing machine, yeah, that one. Yeah, we can see the performance testing of the Turing machine that efficiency of scalability of Turing machine is involves analyzing how machine performs on large input data and resource consumption. So mainly coming to the Turing machine conclusion, the Turing machine initially conceived as a theoretical construct has left an indelible mark on the landscape of computer science from its foundational role in the study. So its variations such as demonstratic and non-demonstratic models and the universal Turing machine further underscore the machine significance and its ability to model diverse comprehension process. By exploring these theoretical underpinnings, practical applications, and practical behaviors of the Turing machine, which moderates the computer and which reads the code to the computer and understanding the technologies and thoughts. So when we come to the functional requirements, input and output, transition rules, tape multiplications, and state transitions, which these are the functional requirements for the Turing machine. And error handling is the main part in the Turing machine, which detects the errors and attempts to move the head beyond the tape boundary. The software shall provide clear errors, messages, and guardian and guidance to the user for corrective actions. So non-functional requirements like performance, usability, portability, and security. The security which defines compromised user data or security or system security. So these are the non-functional requirements. So we can see the documentation, extensibility, and testing. Testing which the software shall undergo through testing, including unit testing, functional testing, performance testing, and usability testing. So these are the four kind of testings which we can use in the non-fictional requirements. So, and this is our the final project which we have done so far about the Turing machine, and we have gained so much knowledge by doing this project.
Yeah, and also we would like to thank our Professor Ali Sharif Ziad, who has given us this opportunity to work with the project. And yes, we have learned a lot through this project. So we really want to thank you, Professor.
Yeah, thank you so much for that.
Yeah, thank you. Have a good day. Bye.